You are welcome to our class. Our second example, we are still on the Laplace transform of derivative. We want to find the solution of this differential equation given this condition using Laplace transform. Now, the first thing we do, we take the Laplace transform of both sides, and that gives this. We have taken L of both sides. Now, after that, we don't need to write out the Laplace transform of this derivative, these two. We need to write out the Laplace transform of derivative, these two, and when we write it out, without wasting time, we are going to have, this for the second one. For the first derivative, we have this is there. This is the minus 5 here. This is 6L. There's no representation. But we can find the Laplace transform of sine 2t. That is 2 over s squared plus 2 squared, which is 4. Now, the next thing is we substitute these values there. So, that will become s squared Laplace transform of y minus s. This one is 0 from the question. This one is 2 from the question. Minus 5 into s Laplace transform of y minus this one is 0 plus this one is Laplace transform of y. This is 6 Laplace transform of y. This is 2 over s squared plus 4. After this, we simplify further. This is Laplace transform of y minus 2. If you expand, we have 5s Laplace transform of y, and last one there plus 6 Laplace transform of y equal to 2 over s squared plus 4. So from this place, anything with Laplace transform of y, we take them to one side. This is s squared. This is another one here, minus 5s. This is another one, plus 6. Laplace transform of y is equal to, anyone without it, we take it to the other side. This one is without it. I'll bring it here, plus 2. Don't forget, as you have brought it here, you need to simplify. Find the LCM. I'll find the LCM. So this should give me 2s squared, 2 times s squared, 2 times 4, 8, plus 2. That is 10. So we should have this one we simplify. If you now make the Laplace transform of y the desired formula, because that is what we are looking for, our answer is 2s squared plus 10 divided by s squared plus 4, this one, times this one, times s squared minus 5s plus 6. We have successfully found the Laplace transform of this differential equation here, given this condition. Next is that we need to simplify we need to factorize it so that we can find the inverse transform. Let's factorize it. 2s squared plus 10 over, if you factorize it, it should give you s minus 2, s minus 3. We still have s squared plus 4 left. So further, we find the inverse transform. That's the next thing. We find the inverse transform of this. In order to find the value of y, we take this L to the other side, so it will become an inverse transform of 2s squared plus 10 divided by s minus 2, s minus 3, s squared plus 4. So this one leads to partial fraction. I've told you I will not need to be showing all those things, so you go and learn it. So I believe the reader must have known about Laplace transform. You know, this one is a over s minus 2 plus b over s minus 3. This one is cs plus d because of this s squared plus 4 here over s squared plus 4. So How do we continue this? Let me begin the solution. I'll just give hint. Our A is or we don't want to do it like that. The way I've explained, you cross multiply. So we have 2s squared plus 10 equal to, you will cross multiply. When you cross multiply, this will not be there again. It will be s minus 3 and this 2. S squared plus 4. For this one to b into s minus 2, s squared plus 4. And finally, cs plus d into this 2. S minus 2, s minus 3. What do we first do? Here, if you make this thing to be equal to 0, s will be equal to 2. Here, if you make it to be equal to 0, s will be equal to 3. We can't do that for this one if you have learned it very well. Now, the first thing is you say let s be equal to 2. Put 2 here. This will be 2 into 2 squared plus 10. So anywhere that is having s is equal to 2 will go. This is having s is equal to 2. 2 minus 2 will be 0. This one too is having s is equal to 2. It will nullify the whole of this. This is what we are going to have left. A into 2 minus 3 into 2 square plus 4. 2 times 2 square, this is 8, plus 10, this is 18. This will be minus 2 square is 4, 4 plus 4 is 8. This is minus 1. So our answer there should be minus 18, minus 8a. Therefore, a is equal to 18 over minus 8. That should be minus 9 divided by 4. So that is our A. For our B, we let s to be minus 2, s to be 3. This one. So this is what we'll still be using. We say let s be equal to 3. From that place, what do we have? This is 2 into 3 squared plus 10 equal to anything involving minus 3 will go. This one is involving minus 3. It will go. This one too will go. This is what we are going to have left. B into 3 minus 2 into 3 square plus 4. 2 square is 8, 3 square is 9. 9 times 2, 18. 18 plus 10, this is 28. 3 minus 1, 2 is 1. So it's gone. 3 square is 9 plus 4, 13. So this is 13b. Therefore, b is equal to 28 divided by 13. So we have known the value of a, we have known the value of b. So there is no more value to use in order to find our answer. There's no more value to use. So we now need to, as you have picked s is equal to 2, s is equal to 3, just pick anything you like. Let's say s is equal to 0. Pick small number. You can pick s is equal to 0. So anywhere we see s, we'll put it as 0. This will be 2 into 0 plus 10. This one is equal to a into, this one will be minus 3 and 4 because s is 0. This is s, it will be minus 3, it will be 4 left. Plus b into, this one too will be minus 2 and 4. Minus 2 and 4. Finally, s is 0, so it will nullify this c. It will remain d left. And this will be minus 2 minus 3. Minus 2 minus 3. Everything on this side will give me 10. Here will give me minus 12a. This is minus 8b plus 6d. Thank God we have known what is our a and what is our b. We only need to substitute. This is minus 12 into our a. A is minus 9 over 4 minus a into b, 8 into b. These are b. 28 over 13 plus 6d. It is now easy for you to find the value of d from this place. Therefore, if you make d the same formula, we are going to have, if you take all this one to the other side and you finally divide both sides by d, so you should be able to have 1 over 26 as our d. So we have known our d. The next thing is, let's represent s to be 1. So you can pick any number. So I'm picking s to be 1. Anywhere I see s now, put it as 1. This will be 2 times 1 plus 10. This is 2 times 1 plus 10 equal to, what we have there is a into 1 minus 3 and 1 plus 4. 1 minus 3 will give me minus 2. 1 plus 4 will give me 5. Plus b into 1 minus 2 is minus 1. 1 plus 4 is 5. Minus 1 and 5. And what we have here is cs plus d. C plus d now. It will be, instead of cs plus, it will be c plus, because s is 1. So this is 1 minus 2. This is minus 1. 1 minus 3 is minus 2. So this will be minus 2, minus 1 minus 2. Minus 1 minus 2. So this will give me 12 equal to minus 10a plus, is also minus 5b. This will be plus 2c plus 2d. This will be 12 into minus 10 into, our a is minus 9 over 4. We have found it. Our b is, this is our b, 28 over 13. We don't know c, but we have known d. D is 1 over 26. Now let us now find the value of c. Let's first make 2c the zero formula. When we make 2c the zero formula, we transfer the rest to this side, so that we are going to have minus 47 over 26. Therefore, our c is minus 47 over 52. Now, where are we coming from? I have even helped you to find everything. So this is where we are coming from. This is our a. Then the inverse Laplace transform. We are going to have y equal to inverse transform of, this is what we will be using now, a over this. So we see that in the other, our a minus 9 over 4. So we have seen that our a is minus 9 over 4 divided by s minus 2, plus our b is 28 over 13. This one divided by s minus 3. We have known our c. Our c is this, minus 47 over 52. So that is minus 47 over 52c plus 47 over 52s, because it is cs, plus d. Our d is 1 over 26 divided by s squared plus 4. This is very easy for us to do. And we'll do this one. We are going to have minus 9 over 4 exponential 2t. This one gives us 28 over 13 exponential 3t. This one, we can separate it. Let's continue writing the inverse transform. This one is easy to do, but this one we still need to do some things. Let's separate it like this. Minus 47 over 52 s over s squared plus 4. And this one is 1 over 26, 1 over s squared plus 4. Now, this one is done already. This 4 means 2 squared. For this thing to become, this is 2 squared. For this thing to become sine, you know this one is sine already. Whatever number that is here must be on top. As I've explained before, I'll put the number there, which is 2. I'll say times 1 over 2 again. So at the end of the day, my answer should be minus 9 over 4 exponential 2t plus 28 over 13 exponential 3t. This is minus 47 over 52. This should be cos 2t, and finally this should be 1 plus 1 over 52 sine 2t. So that is the solution of the given differential equation. So let's take another example. To find the solution of the wave equation, find the solution of this wave equation. So using Laplace transform, we want to use Laplace transform to solve it. Now the first thing is we take Laplace transform of this plus Laplace transform of s is equal to Laplace transform of cos 2t. This is just the same thing as this. It's just that y is being represented by x. So it's still the same thing. So it will be s squared Laplace transform of to be s squared Laplace transform of x minus s prime of 0 minus this minus ordinary this, and finally we have s prime of 0, just like what we have here. This is s y naught, so this one is just s naught as well. It is this one that is s prime. There's no first derivative. This is just Laplace transform of s. We have no Laplace transform of cos 2t to be s over s squared plus 4. The next thing is we substitute these values, and that will give me s squared Laplace transform of s minus s into 0 from the equation. This one is minus 1 plus Laplace transform of x equal to s over s squared plus 4. This is 0 already. Anyone with Laplace transform of s, let's bring them together. This is this Laplace transform of s. Anyone without it, let's take it to the other side. This is minus 1. We take it to this place, it will become plus 1. It's still easy at this level. Therefore, Laplace transform of s will now become s over, we divide both sides by this, s squared plus 1, s squared plus 4 plus 1 over s squared plus 1. So that is that about that. This one is separated already. We apply Laplace transform of, we apply partial fraction here in order to find the x. So we find the inverse transform, that is s squared plus 1 s squared plus 4 plus 1 over s squared plus 1. So that is the inverse transform of the, we want to find the inverse transform, so we apply partial fraction. Now when we apply partial fraction, I don't need to do that. We are going to have, so we are going to have this when we find the partial fraction. We are going to have s over s squared plus 4, then this one is there, 1 over s squared plus 1. Now let's find the inverse transform directly. If you find the inverse transform, this one is very easy. This is cos t. This one is minus cos 2t. While this one is sin t, inverse transform. Therefore, our s of t is 1 over 3 cos t minus 1 over 3 cos 2t plus sin t. So that's our answer. That's the solution of the wave equation. So you need to know how I move from this place to this place, the partial fraction that I apply. You need to understand it. So let's take the following assignment. So we practice this assignment, these questions. Just practice the question. Find the Laplace transform of the following differential equations. So this is differential equation, this is the condition. So we can see it. Now, that is for number 1. For number 2, find the solution of the following differential equations using Laplace transform. So we find the solution. This one is just to find the Laplace transform. This one is find the solution using Laplace transform. We have another one here. And this is an application. This is an electric circuit application. An inductor of L Henrys and a condenser of C Faradays are connected in series. I've used the series to form this differential equation. So I've used this series to compute this differential equation. So this is the Henrys here. So we need to, and this is the Faradays here. So we need to take the Laplace transform of this. It's just the way, it's just like all these ones too. And find our answer. At the end of the day, Q will come out. The question says, the second question says you should find the expression for I. I is the current, which is the Q dt. Whatever you get here, you differentiate it to get your I. So the initial condition is given. I of 0 is 0. That is, and Q of 0 is Q naught. It is not 0, it is Q naught. Q of 0 is Q naught. This is it here. Another one here, we have a resistor of 10 ohms, an indicator of 2 Henrys, and a battery of volt E are connected in series with switch S given by this. So we have it has been computed in this differential equation. So find the solution by Laplace transform. If this E is, I've used all this ohms and these Henrys to compute this differential equation for you. Normally, I didn't supposed to do so, but you don't know about it. I've computed it in a differential equation way. Your own is just to now use Laplace transform to solve it. The first one when E is equal to this. The second one when E is equal to this. So have a nice day.